In the second part of this video series, we left off after discussing a 3 chiral center separation and how to deal with the complexity of that mixture of 8 individual isomers. At the completion of that separation, we had developed a fraction tree in which individual isomers required no more than 2 SFC preparative methods. We were able to identify those SFC preparative methods very rapidly, and at the end we not only had certainty of completion of each individual fraction, recovery at high yield, but also we were able to assign, based on HPLC retention time, the individual pair relationships of the enantiomeric pair relationships of the individual isomers. Let's take one more quick example. Here is our UPLC resolution that allows us to assign unique retention times to 4 different enantiomer pairs. In this case, we also have abundances of 2 of them at reasonably high level and 2 of those pairs at fairly low levels. The peak at 1.32 turns out to be an impurity. As before, we develop an initial preparative scale resolution. It's not dependent on being able to separate all of these individual isomers into discrete bands because we can leverage the UPLC assignment of the chiral relationships between the bands to sort out what's happening in this separation. So we collect fractions 1 through 4 from this separation. And using that UPLC chromatogram, we can determine that F1 contains 2 individual diastereomers, F2 contains 3, F3 contains 2, and F4 is the only fraction here where we've completed the resolution of one of the 8 individual isomers. Now, of course, we have developed a set of screening chromatograms earlier in this experimental train that give us stationary phase interaction, and the first thing that we'll do is go back and screen fractions 1 through 3 against those stationary phases where the compound interacted, where the sample interacted, and that will give us our subsequent separation steps. So our final fraction tree, in this case, again, no more than 2 methods are required in any case to produce a pure fraction. We know when we've completed the work. That completion of isolation that's so important to us, we don't have to go back and randomly screen again, is a relatively fast process. And again, to do a 1 to 5 gram smallish sample requires no more than a few hours in our hands. We're able to sort out the pair relationships from our UPLC chromatogram, but chemists find that NMR data is definitive, and so what we've done in this case is we've assigned the pair relationships to another degree of certainty by looking at the NMR data, and you can see the pair relationships if you look closely at the NMR peaks in most of these, but again, those pair relationships are pretty obvious to us already from our UPLC screening chromatograms. So, summarizing the work that's been presented in these 3 brief videos, we use gradient reverse phase UPLC with little optimization, really. We simply use a fairly broad 5-minute gradient for most of the samples, to resolve and assign retention times to each enantiomer pair. So if it's a 3 chiral center molecule, we'll have 4 enantiomer pairs, and each one of those will be separable to give us 8 individual isomers. That initial chiral SFC separation does not need to be complete. I think we've all fallen into the trap based on one chiral center molecules of wanting to see each isomer in our separation in order to move to preparative scale and begin processing chiral resolution. We don't need to do that in this case. We generally separate 3 to 5 individual fractions and begin to sort things out based on that UPLC overlay of data. That gives us the locations of each isomer, and the pair relationships are known. We get that from relative retention time, and we get that from relative abundance in the chromatograms. The fractions are that are collected are reduced in mass, and so they're faster to process. They're enhanced in purity. Generally, impurities are removed. So subsequent processing is usually very efficient. The greatest benefit of this approach is knowing when the resolution is complete and therefore comprehensive. You can get to a complete answer fairly quickly. Our typical timelines for 3 chiral centers, 2 hours minimum, maximum of 8 hours to generate, well, for around a 5-gram sample to generate 8 pure isomers. Again, recoverable in high yields. And our methods are reproducible and therefore scalable, so that we can produce more if a future sample at a larger scale becomes available. I want to thank everybody for their attention to these videos. I hope that you gain some benefit, and please reach out with questions in the future. I look forward to talking with you.